Question 2C says, find the acceleration of particle Q at time t equals 1. Is the speed of the particle increasing or decreasing at t equals 1? Okay, so the first thing we want to establish is when does speed increase and when does speed decrease? So speed is increasing when the velocity and acceleration work together. So if our velocity is to the right and we're accelerating to the right in the same direction, speed will increase. Speed is decreasing when velocity and acceleration work against each other or in the opposite direction. So when v is to the right and a is to the left, they're working against each other, and so the speed will decrease. Okay, so let's do the first part here, find acceleration. So the acceleration is going to be the slope of the velocity function. So we could find the derivative of velocity and work that out, but since this is a calculator section, we should just use the dy by dx function, the slope function on the calculator. So I'm going to go to my calc menu and I'm going to find the dy by dx at x equals 1, okay, or when t equals 1, and my calculator calculates that the slope is going to be 1.034. So that would be the first part. The acceleration, so I'm going to call that a of t, or a of 1, is equal to 1.304. Okay, and that's going to be in units, and we'll just say that's minutes squared. Okay, they don't actually give us the units, but it's units, the distance units in per minute or per time squared. So that's our acceleration. Now, to answer the second part of this question, the speed increasing or decreasing, we have to establish what the velocity is. So we're going to calculate the value of the velocity, and that's directly off the graph. So we can calc value. So we can use number 1, calc value, and we're going to calculate the value of the velocity function when t equals 1, and we can see that from the graph that the velocity is equal to -1. Okay, so the velocity is equal to -1, so I'm going to write this down. V of t, v of 1 equals -1, and that's going to be units per minute. And since they are working against each other, the speed is decreasing because we have a velocity that is going in this direction. So that's going to be -1, yet we have an acceleration working against it, working in this direction. In terms, it's going to be positive 1.304. Okay, so since the velocity and acceleration are opposite signs, its speed is decreasing. So speed is decreasing. Since acceleration a of 1 and v of 1 have opposite sides. Okay, so that's part C. Part D, find the total distance traveled by particle P over the time interval 0 to pi. So we're going to go to the P graph. So this is my V of P graph. And we can see that there is some distance, or the area, which would be the distance, the displacement, or distance covered, or that, sorry, the area would be the displacement, and part of it's above and part of it's below. So since we want distance, and it's key that we need distance here, not displacement, we need to take all the positive distance and add that to the opposite of all the negative. So we need to make that negative distance positive. To do that, we need to know at what point it crosses the x-axis. So that's the first thing we're going to do, is we're going to find the 0 of that point, and we're using our calculator to do this again. So we're using the 0. Okay, I think I highlighted it down here. So the 0 number 2 is 0. We're going to calculate the 0 as 2.145. And we want to then integrate that from 0 to 2.1.145. So the distance is equal to the integral from 0 to 2.145 under our Vp of t plus the negative, or the opposite of the area from 2.145 all the way to pi under that same graph. And when we calculate that, again, we're going to use the integrate function. Okay, we're going to use it number 7, the integral of f of x dx, and we get the area above is 1.223, so that's equal to 1.223 units, plus the opposite, I'm just going to write that as minus, and that area is going to be negative, so that area is negative 0.708, and combining those together, we get the total distance as 1 point, I think it have down here, 931. Okay, so that's the total distance traveled. And we can do that by summing up those two separate areas. Okay, to do that, we do need to find the intersection point so we can split up that integral at 2.145. Now, there is a cheat for this, and we can graph this with the absolute value, and then we can integrate all the way through from 0 to pi, and when we do this, we get directly the area of 1.931. Okay, and that will give us the same answer, but it's slightly more efficient because we don't have to split up the integral. In fact, we don't have to solve for that point at which it goes from above to below the x-axis.